So that's HR17 hybrid machine. It has error code 47 when you're trying to operate a couple functions at a time from the basket. So we're gonna try that and see if it's gonna fail. So at the moment it started up, so PLC is flashing green. So let's go and try it from the cage. So I'm in a cage now, so I'm gonna try to operate on electric power. Using telescope in, so I'm using tele in function. It's closing in, and I think the customer said if you use two functions at the same time, there may gonna be error. So I'll do which one should we do? I'll do cage rotate and the tele in. Let's see. So holding two functions at the same time. And now it stopped and I got error 47. Okay, wait a minute, let's try again. I hope you're gonna be able to see the screen. So I'm gonna restart the power now. So machine is off. Start it up again. I wonder if it's actually the cage rotate that is triggering the phone. So I'm going cage rotate only, yeah. Go rotating to the left. Okay, no errors here. Rotating to the right. No problems. Okay, tele out. I'm gonna do tele in the ended, and then maybe cage rotate or a fly down with this function. So holding tele in, come down on the fly. So in here, cage rotate and error 47. Okay, so if I do cage rotate and the tele in function, that gives us error 47, 37 and 23. So let me try a different one. So I'll reset the power. I will try together with the primary boom or laughing boom. So laughing boom down is running and rotate. Okay, so it's not as bad. Okay, so no errors. So I don't think it's linked actually to the cage rotate. It's maybe actually linked more with the load on the system. Because if I do tele in, I'm not sure if you can hear it, but hydraulic load, I think, or a motor load is different. It sounds like an electric motor is bogging down and it's nearly stopped. And the function is very, very slow. I wonder if it's going to be linked to that, because that's where you would get your error 47 if you're having issues with the power supply. There we go. So hit that ended, increase the pressure, and I think that caused the error 47. So looking into errors now, error 47 I think is a primary error here, because error 47 is saying that we lost the power here in the console, and the error 37 means that the PLC communication issue with the PLC at the base, and error, I think what's the next one, 21 or 23, we have 23. So error 23 is actually saying the joystick is off the canvas. And when you think about this, all makes sense, because if you lost the power in the cage, then the PLC shut down the relay that is powering the joystick. So we lost the power supply to the joystick. That would be error 23. And as well, the PLC shut down, so it's not communicating with the base PLC, so it's not getting the parameters. So it's error 37, and the 47 is under voltage error. So I think I will start with the basics, and we're gonna have a look into the battery voltage, what is happening when we underload. just in case if that is too low and is causing the step down unit to shut down. So I plugged my multimeter on the controller, so we have a B minus and B plus, so that's our high current supply to controller, and at the moment it's reading 50 volts. So we'll try to do the functions, and we're gonna see how low it is getting to. Okay, because my suspicion is that something's going on with this power supply, otherwise why would it trigger error 47, or why would it bog down when you do two functions? Okay, so the voltage is there, display is here, so I'm gonna do maybe cage rotate only. It's 47. Okay, and I will do tele in, so holding tele in, cage rotate. Okay, error 47. Alright, let me try it this way. I'm gonna restart the power now, so you can see the capacitors is discharging on the motor controller now, because I switched the power off. It's all back up, it's good. So now I'll do min and max, and we're gonna try to read the minimum voltage on it. So we do cage rotate, tele in, so no errors. So tele out and a cage rotate at the same time. Tele in, okay, so it dropped out the minimum 44, so the 44 is not as low, so still enough to have to keep the step down unit up and running. So yeah, let's try. See what else we can check. Okay, so next thing I want to check is the power supply. So the power supply to the cage goes from terminal T6 and T7, so the brown and blue wires, and that's a feed to the cage, and we need to check to see what sort of voltage we have. So I'm going to try to get my multimeter in here and operate from the cage and see where out in terms of voltage, how much voltage we're supplying, and then we will see how this thing is wired up, because in many cases I've seen this not being wired up correctly, and that can cause an error 47. So we do with the power supply first, and then we see where we are. So multimeter is here, measuring brown and blue wires, those ones here, and I have 13.4 without any load. The machine is on, so no errors at the moment. I'm gonna try to do cage rotate, and that gave me error 47 right away. So you possibly noticed the voltage didn't drop down too much. Okay. Interesting. So supply is good, I think. I wonder if there is going to be something to do with this connector. This is broken, snapped off, and the power goes through that connector. I'll try to move it around as I operating the function and see, or not as operating function, but I will just go on the green button, so the motor is running, and I will try to move that connector, see if it's gonna trigger the error. Which is not. Okay, let's get read the voltage inside the console, because we had a 12.5 on supply. So let's see what this actually comes all the way to the console. So that's the wires from that broken plug. Comes all the way to the board here, blue and red. And we're gonna measure the power supply on them. See what we're getting. Cables in there, measuring the voltage. Cage rotate to the right. So it's not that bad. Move the connector. And I cannot get this to fail, so voltage is good, 12 volts. So I managed to get this to fail a few times, but I think what is actually happening, the voltage is dropping down fast, so I cannot pick this up with the multimeter. And connections are looking good here, so I think what I'm gonna try to do is I'm gonna try to simulate a drive, fast-speed drive, and the steer at the same time, and that's gonna be the highest possible load on the control circuit, and we're gonna try to pinpoint it that way. So first I'm gonna try to set the machine up with the dummy coils. So inside the chassis I have a drive valve. I have 2 coils here for the drive. So that's my drive back, I think, and that is my drive forward. So drive forward has no clip on it, so could be issues with the drive, but drive forward. Okay, so I'll take the 2 coils from the booms valve block. So I'm just gonna take 2 coils off here to use them as a dummy coils. So we can have a loaded circuit, but machine will not move, so I can do tests more conveniently. So this is those 2 coils. I plugged it on the drive leads, so we can drive the machine without triggering any errors related to the drive solenoids. But we're gonna have machine nice and stable, so it's safe to move around, and we can do some voltage checks. Okay, so measuring voltage now, and I'm gonna try to do driving, but I think actually I'm gonna put the console down so it's gonna be easier to show. So I am at the speed 3, and I'm gonna go for the drive, press the trigger, forward drive, so machine is not moving, but I'm loading the coils with the full current, so the voltage is 11.8 and we have no errors. I'm gonna start steering, and I'm expecting that that's gonna trigger the error. So I'm gonna go left. So voltage dropped 11.5, but we don't have any errors, which is a good thing. So I wonder if it's actually problem is not a power supply here, because normally if you have issue with the error 47 is the voltage drop on the supply, but now we're going in fast speed full load on a circuit, the voltage is at 11.6 and there is no error codes. Okay, let me try to do cage rotate. Look, with the cage rotate we got error straight away. So it's actually the cage rotate that is triggering the error. I wonder if there's actually problems with the wire that is feeding the coil, because you have a coil on the diverter valve here. I'll show you. Here we have the diverter valve, which is operating. When you go to the cage rotate, it enables that coil. So I wonder if there's any problems here. I will check the wire for any damages, and then we'll check the coil. So that doesn't look that bad, so I can't see any obvious damages at the moment. So I will take the plug off, and I will check the resistance on that coil, see what we have. So before I do resistance check, I thought I'm gonna try to operate the cage rotate without a coil, and then obviously my jib or fly is gonna go up or down, but I wonder if it's gonna trigger any errors. So it's not triggering the errors. Okay. Alright, let me check on that coil then. So coil resistance here is 5.7 ohms. So that's not bad. It's not shorted out. The progress is in such a way that I'm testing everything what I can see here on the board. But I'm looking on this supply, and this is the power supply is good. So I have a 13.3 volts, let's say. And if I go to cage rotate, it drops down, let's say 12.2 or so. Okay, so it's not as bad. But the next one here, ESR, so that's E-stop return. If you look on that one, you will see it's a bit stranger one. So it has 11.8 to start with, and then if I go cage rotate, it drops 10.2, and I think now I may got error code. Yeah, and now I got the error code. So it goes very close to 10 volts. Okay, so I need to figure it out why we're dropping so much, because that diode is giving 1 volt drop. I'll do a diode test quickly here. So look on the diode, I have with the green button I have 12.7, and then if I go across it I should have 1 volt drop, or 0.7 ideally, but it will depends on the temperature, but it's 12 volts. Okay, so that's not bad. But if I measure here, so it's 11.8. So I'm losing the voltage somewhere. That goes from the diode on the supply to PLC, and the PLC supplies those red wires here. So I'm losing voltage for some reason there. 11, 11.8, 11.8. So I have a feeling that's gonna be something to do maybe with the connections. Alright, let me check where that diode goes to, and I think there's a plug underneath. So I think the way it is, so we have this diode here, so the voltage goes from that diode into connector here. You see there is a, so this is a function of the fly, so let me remove them so we don't get confused. So there is a terminals behind that, so this terminals here, and I have good supply on this terminal, which is feed from the diode, and that's returning, and that's 11.8. so I'll show you now. So look, if I'm measuring on this terminal right there, so I have a good 12 volts, 12.1, and if I'm gonna move across, I have 11.8. So I flipped the console over, and we're actually measuring this connector here. But the interesting thing now is, when I do the same voltage test on the connector, look, I have 11.8, where when we're measuring this pin from the other side of the board, I have 12. So I'm losing over that connection here. So you see the way I'm losing on a crimp or on a plug, or something to do with the pin. So let's have a look at the plug and see what we have. pins are looking not too bad. I mean, it's definitely has some marks of moisture, I think. I'm not sure if you can focus on that, but there is definitely some problems with the watermarks there, I think. That's the wires, kg stop feed and kg stop return. So I don't have, I think, the same plug. I will have a check. Just trying to remove that connector, but it's even with the great difficulty I cannot get those wires out, both of them. They are sitting here solid. That's not a good sign. So I managed to pull them out, and you can see the level of corrosion is pretty high. So I'm not surprised we're getting voltage drops there. And that is the crimp in a beautiful hands. But you can see it's corroded pretty badly. I don't know if the camera can actually show the level of corrosion there, but visually it's really bad state. So it definitely needs a new connector. So I should say I'm pretty lucky, so I have a new connector here with me. So we're gonna put a new plug on, and hopefully that's gonna be end of the troubles here. But I think I may gonna have to recrimp the ends on these wires because I don't like the way they are corroded, and I think if you leave them like this, it's not gonna be great, or it's not gonna last long. So yeah, let me do that. I will recrimp the wires, and then we're gonna reassemble with a new connector. Okay, so wires recrimped, reassembled on a new connector. Let's put it in. Let's reassemble all together. Or actually, you know what, we're gonna do the voltage check on. So remember we had 11.8 on this connector. So let's see what we have now. And now we have a 12.08. So that's the same voltage we had with on a diode. Remember we checked the diode, so we had 0.7 volts drop on a diode, and that diode is supplying this pin. So on the opposite side of the board we had a good supply, on this side we had 11.8, and look at this now, it's 12.10, and the next one down is 12.10. So I think that's gonna be end of the troubles here. So we actually managed to measure a voltage drop across that connector, and the state of it was really bad, as you've seen. So let's do some more testing now. I'm pretty confident that's gonna be end of the troubles here. Okay, it looks like it's gonna be fine. So I will reassemble everything together, and I'll do some more testing, but the way I see it now is we definitely nailed it, and we found a problem. We managed to prove that, to measure the voltage drop on the connector. We visually inspected it, and we seen the corrosion on it. So you know, with the corrosion is such a thing that the heavier load, the more voltage drop you're gonna get. Just been testing for a while now, it's all working fine. The other thing I want to show you, if you have a problem with error 47, look at these connections here. Make sure it's nice and tight. You see this is a bit loose, so I will try to tighten up, making sure that everything is nice and tight here, because the voltage drop across these can generate the same error 47, and the same goes with this e-stop normally closed connector and the key switch connector. Yeah, so if you have error 47, make sure these are good and there is no issues here with the connection on this diode bridge. As well, if you disconnect a wire, 12 volt VSD, which is a 12 volt supply from step down unit, the machine should stay on. So now you have a PLC flashing green, the machine is on. If I remove that wire, the machine should stay on. You see, it died out. So that's something that's not right here. So I think some of the wires are in the wrong place, because you shouldn't have a voltage coming into the control circuit from the 12 volt battery. So let's do some measurements. So I'm gonna check the 12 volt battery. and I have a 12 volts. That's good. So let me see if I can locate this here. Okay, so 12 volts from step down unit should be coming through this cable, and we have 14.4. So that is coming through the 12 step down unit. Here is a voltage converter, yeah, 48 to 12 volts. Now we should have a 12 volts coming on this one of these. So we have 0 here and we have a 0 here. So we should have 12 volts on one of that connector or one of those wires, which we don't. And a reason possibly why we don't have it is going to be inside the chassis. You see that this connector here, that what should be carrying the voltage over, and look at the state of them. So I think that contact possibly needs to be replaced. Okay, let's see if anything has changed. Nothing. So that means we don't have a connection to 12 volt battery, and it's not gonna trickle charging through a resistor and that bridge. It's not very good. And I think that's the wire that comes from 12 volt battery here. I wonder, is this the right one? Yeah, it could be. Let's see what's happening there inside the chassis. Yeah? So I'm gonna try to measure the voltage in here, if my ground cable is gonna reach. So 12.54 on one, so that one here, and I have 12.54, and this next one I have nothing. Okay, so if I connect the power on that here, I should have a voltage on this contact, but I don't have that. Oops. Yeah, I think the problem is that contact on the back of the isolator, because I'm getting the feed to it, but it's not passing over the contact. You see there's a small contact on it, so that small bit here, and it's not looking great anyway, and I cannot get this to work. Yeah, okay, so that needs a new contact at the back, so the machine should stay on. And that is kind of like a backup supply to control circuit. So if that is not working, then you would get error 47 as well. Look, I just put a fuse here in those two wires. Okay, so that's just simulating that contactor operational. Just want to show you. I'm not going to leave it that way, but I want to show you that we have a 12 volt step down unit disconnected. Okay. And look, machine now is on. See, the PLC is flashing. And then we have a supply 1146, and that's 12.23. Okay, so it does have a power coming in and going out into control circuit over the diode, and then when you plug the step down unit, so the voltage at the control circuit will increase, at the same time increasing the voltage on the battery. You should start charging the battery slightly. Yeah, so that's how this combination is working. So it is important to have a supply from this battery, because you can trigger error 47 as well. Alright, I think that's all done. Do a bit more testing, but I think it's all gonna be just fine. Okay, so tested it out, and been using for a while now, so it's working fine. I can't get it to fail anymore, so I think that's a win-win. It was not easy to find, so it took a while to figure out what's going on, or where the voltage is dropping out, but I saw it for the measuring the voltages and trying to understand where the actual problem is. We were able to find a plug badly corroded and creating the voltage drop. So it's all good for now. So don't forget to like and subscribe, and I'll see you on the next one.